so that actually you could able to run not only your workloads or applications, but even the agentics, LLMs and other stuff also in the edge side. So hopefully that going to be a future architecture around it, because we want to enable the people to access these LLMs as many as possible down the road, which means these computation need to be available to be very local to the people. So that's what the problem statement that we are going to solve around this one. But again, this does not cover anything around the LLMs. This is pure platform engineering. So I might not satisfy everyone in this session. So the agenda of this session is more around the what is edge computing, what are the tools and technologies that are available to do the edge computing, and then actually what are the different type of edge patterns that we actually have, and then last one is actually a small demo around how we can deploy a large scale Kubernetes cluster in a small capacity, and then actually have any questions around it. So I just put this slide to give you the confidence around why the edge computing is necessary. So it's more around, currently the trend is more towards is actually because most of where your data is generated, right? Let's take retail as an example, healthcare domain as an example. From morning on, people are talking about healthcare domains as well, right? Your data resides where your users are actually, right? Not that in the cloud, right? So your data is generated at where users are. For example, let's take as retail as an example. Take any retail store. All the billing and everything actually happens locally. It's not in the cloud, right? Not in the cloud, not in the data centers. So, which means what people are trying to achieve is actually how I could able to deploy my applications very near to the users, so that actually even in the worst case scenario part, or if there is an outages or any case scenario, still I could able to run my business around it, right? That's where the whole edge computing came into scope. It is not new, again. So very big enterprises are already been doing it with a very large scale, but this is a minimal version of it. And the business is growing a lot, especially when the LLMs came into the scope. People want to deploy these as LLMs very near to the users, so that actually is accessible to the people, and then they are able to perform everything at the edge itself. So the trend is going up and up, which means for platform engineers, still there is a hope. It won't be replaced by the AI, at least in the current case scenarios. So how we're going to achieve this is actually there are a lot of tools are available. So tools name called Yocto, Kiwi. There are tools are available to build these edge build images. But in this session, we're mostly covering these SUSE edge cases, SUSE edge products. So this is very purpose built for building your edge computing images. So if you want to run operating system, right, you need to build an ISO first, and then become a bootable disk, and then upload that, and then boot it, and then start to build your Kubernetes clusters there, started to deploy your application for the first day, and tomorrow, and then you have to do the day 2 operations, you need to continuously release your applications, and you need to do all that sort of stuff, right? So there is a lot of manual things that need to be done, and it is, if you're doing it with cloud, you have GPU, EKS, lot of Kubernetes platforms are available, so you could go one-click deployment, it does everything for you. But in edge, it's a different story. So edge is equivalent to your data center, but a very small scale data center. And let's take a case scenario. If you look at the Apollo Pharmacy, or if you take it or DMart as an example, they have 400 stores. What is the case if they want to do the edge computing at 400 stores? Now you need to run these things on 400 locations, which is a pretty hard to do it, right? That's a very big problem statement to solve around it, right? You could procure the hardware, but the first thing is actually how you deploy your operating system and how you run it, right? Hardware platform engineers and Pixie Boot and other stuff, but you deploy your operating system, then what? Right? You need to deploy your clusters, you need to deploy your applications, you need to do all this other stuff. That's what this SUSE Edge actually does. So it's a bunch of tools together, work together to solve the problem statement around it. So I'll talk about the higher architecture, and then I'll run a command, because that command will take at least 15 minutes to run. Like LLM, it needs a large computation. So just to build that image, I need minimum of 8 cores to 16 GB RAM. So I'll run that command so that it will be done in 15 minutes, so that we'll be ready for the demo around with it. If that fails, I have the backup image, so I'm showing that. So as I said, there are two major components within the edge computing side. One is the management, where we sit and then do all the operations around it. And then we actually have a downstream, where you actually have your edge clusters, edge nodes of the edge clusters. So on top, top level also you actually have Kubernetes, you actually have a lot of other components. So one component called Elemental, I'll talk about the importance of these tools. And then there is another component called Elemental. One is called Metal 3, that you can see from the top red one. The orange one is the Elemental. And then there are a couple of tools. Whoever knows the Kubernetes, they might have already been used or experienced the Rancher. So it's a SUSE product again now. So it uses those components to do all the operations in the downstream clusters. That's what the whole architecture. So it's a very simple and straightforward. Most of these things are decoupled in nature, which means every tool is free, but you have to combine together to use it in your use case. SUSE Edge actually works together all together. Every product is, whatever you actually see it here, everything is completely open source. Nothing is enterprise, only enterprise is support. So the first part is actually right, you need an ISO image to boot your system first and then actually deploy it. So that's what the Edge image builder does. You might see if you search for Edge image builder, you will see a lot of image builders, but this is very specific for the Edge computer. So what it does is actually, it uses something called SLE Micro, SUSE Enterprise Linux Micro. It's a very lightweight operating system. And then you define your declarative configurations, saying that actually, okay, what you want to run, what you want to deploy, what you want to load into the image, all the stuff you define it, build it. Once you build it actually, you will get an ISO file. And you take that ISO file, and there are 3 ways to be able to do it. Okay? That's where the deployment strategies comes into the scope. One way is actually, you know your hardware. Saying that actually, you procure a hardware, put it into your edge locations, and then you want to boot it from where you're sitting, right? That is the direct and network provisioning, which is, you already know what is your physical hardware, what protocol they support. So there is protocols like DRAX, Redfish, there are other protocols that are available. So which is very simple terminology is actually, your hardware is available through API calls. Okay, so that's where the red one that we talked in the diagram, which is called Metal 3, that's what actually handles everything together, and it connects to the hardware through APIs, loads this ISO, do the Pixie boot, install everything for you, and then your cluster is up and running already. And then second one is actually, you have your hardware, but you don't know what is that hardware is. You are not aware of it actually, whether it is Sun Microsystems, whether it is servers coming from the Dell. You don't know anything about it, but we have the servers are already there, right? In that case, whatever the image that you might have been built, you take that image, make it as a bootable, load it to your system, and then afterwards actually, what happens is actually once you load it, that will register to the top level cluster, and then the resources are available there. Once the resources are available there, then it will pick out and then install whatever the necessary things that need to be done. Third one is actually the air-gap environments. This is very specific to, for example, especially for the airplane services, and then very edge case scenarios where you don't have access to the internet, you cannot do anything around with it. And in the demo that we are going to cover is that only, so that actually I'll disconnect the internet and I'll try to put everything together at once. Okay? So this is how the definition file looks like. It's very simple and easy. So you choose your image, the base image. If you know Dockers, it's almost the same way. So you have a base Docker file. Within the Docker file, you define the base, and then you actually write all the commands that you want to do. Rather than writing the command, define how many users you want to create, what is the Kubernetes version that you want to deploy. Especially for air-gap environments, you don't have access to the internet, which means you want to load all your applications when you're building itself. So that actually take that image, load it, it's already up and running, right? So you define all the other stuff, and then actually next step that you're going to do is actually you load it. So that's what I'm going to demonstrate now. Let me take you to the ISO file that I actually have. So this is an ISO file that I actually have. I'll explain you the basic components of the ISO file. There are a lot of things. I'm only covering certain aspects around it. So as I mentioned, you have a baseline operating system. You have multiple users that are actually defined here. And then I'm saying that actually I want to have certain packages need to be installed to do some other operations around it. And then I said I want to deploy my Kubernetes cluster. So again, in Kubernetes, there are different distributions that are available. If people know Kubernetes around with it. One is actually the generic, it's called vanilla Kubernetes, and there are other flavors that are available called lightweight Kubernetes, Micro K8s, K3s, There are uh, there is something like K0S as well. So it's a very, very lightweight Kubernetes clusters. So we're going to deploy that very lightweight Kubernetes called K3s. And then what I'm defining is actually, I'm deploying a headlamp. Headlamp is actually Kubernetes dashboard tool. So I'm deploying that. And then actually, because I want to build this for a air-gapped environment, I'm loading all the necessary images into it. So that actually, I don't need access to the internet at all actually. So this is the very basic configurations. And along with it, I'm doing other pieces. If you look at the stuff. So I'm loading a simple Nginx application. And then I'm overriding certain configurations of my help deployment, which is headlamp application. And then I'm setting up my network configurations. So if it is an air-gapped environment, there are two options that you actually have. You might have a DHCP server, you might not actually have a DHCP server. You want to split this static IP and all the other things. That's what it is actually doing. And then there are other things that you can able to do. You could load your own RPM packages. You could do all the other things around with it. I try to keep it as minimal as possible. I'll run this one, but I already ran one of it. But I'll run this one. This is very resource in this application. So what it is doing is actually I defined a help chart. So it is pulling that help chart because I defined certain RPM packages. It is trying to install that itself will take 3 to 4 minutes because it has to go to the internet, download that RPMs, make it locally available so that actually when you boot it, they don't need to be pulled again. So let this one get done. But I already, as I said, I already built an image just before this call. So I'll try to load it out and I'll actually show you what actually happens. So I'll disconnect the internet for now. And load the UTM. So again, UTM is actually like a virtual box, if you guys are aware of it. I'm loading an operating system. I'm using Intel virtualization. So Apple virtualization. I built that image in the desktop. So I'll just load it. Continue. Again, I'm looking at food. Again, I don't have access to the internet now. Hoping that actually the demo will be successful, but let's see what happens. So again, I have to be very specific because I choose the network set to manual, which is the IP had to be manual. It will assign these IP addresses based on the MAC addresses that actually configured. So what I will do is actually I'll pick up the MAC address that I might actually configure in the values. So I have the MAC address somewhere actually here. Put that MAC address actually here. This is not a shared network, this is a virtual network, so that I will be able to load the application. Okay, I'll save it and I'll do it. Now it's as similar as to how you load your Windows operating system. You might not be able to see a lot of stuff because the reason is actually the way the display drivers are, so you might not be able to see it. That is the reason actually I set up the bridge network, so that actually I should be able to access the application from outside of the system as well. So let this one get good. It doesn't take much time, hardly it will take 2 to 3 minutes because everything is already preloaded, right? Nothing needs to be pulled from the internet. So if you can actually, even I cannot even see anything. So there is something called combustion. So combustion is actually similar to the cloud image script that we actually have in the usually have it in the cloud platforms. So in the cloud platforms, you write a cloud image script saying that actually install these things, configure these parameters, and all the other stuff. It's similar to the same. In SUSE Linux, they usually call it as combustion. So that's what it is, combusting. So which is actually it's burning the configurations to write the files in the right place. Now it is actually doing it. So it's already loaded all the Docker images that we actually been mentioned in the configuration already. Now, it is installing the Kubernetes. It's already installed the Kubernetes. So I have right to log in. actually see the node is already up and running. Like, you might not be able to see, here it says it is already in ready state, which means the cluster is already up and running. So let's see the pods.